Input and output, or I/O, is the communication between an information processing system, such as a computer, and the outside world, possibly a human or another information processing system. Inputs are the signals or data received by the system, and outputs are the signals or data sent from it. Our objectives in this report is first, to be able to define what is definition of input and output, to be able to provide what is interface and higher level implementation, and lastly, to be able to define difference of channel, port map, and DMA. Hello guys, I'm Kenneth Banaban and I will be reporting input and output. In computing, input or output, I/O or informally small I/O or big I/O is the communication between an information processing system, such as a computer, and the outside world, possibly a human or another information processing system. Inputs are the signal or data received by the system, and outputs are the signal or data sent from it. The term can also be used as part of an action. To perform I/O is to perform an input or output operation. I/O devices are the piece of hardware used by a human or other systems to communicate with a computer. For instance, a keyboard or a computer mouse is an output device for a computer, while monitor and printers are output devices. Devices for communication between computers, such as a modem and network card, typically perform both input and output operations.
I'm Raf-Raf Gabino. I'll be discussing higher level implementation. Higher level operating system and programming facilities employ separate, more abstract I/O concepts and primitives. For example, most operating systems provide application programs with the concept of files. The C and the C++ programming languages and the operating system is the Unix family. Traditionally, abstract files and devices as streams which can be read or written, or something both. The C standard library provides function for manipulating streams for input and output. Higher implementation, an alternative to a special primitive function, is the I/O monad, which permits program to just describe I/O and the actions are carried out outside the program. This is notable because I/O functions would be introduced side effects to any programming language, but this allows purely functional programming to be practical.
I'm Julien and Aurelio. I'm gonna report about the channel input-output. Channel input-output. In computing, channel input-output is a high-performance input-output architecture that is implemented in various forms on a number of computer architectures, especially on mainframe computers. In the past, channels were generally implemented with custom devices, variously named channel, input-output processor, input-output controller, input-output synchronizer, or DMA controller. Channel architecture avoids this problem by processing some or all of the input-output tasks without the aid of the CPU by offloading the work to dedicated logic. Channels are logically self-contained with sufficient logic and working storage to handle input-output tasks. Some are powerful or flexible enough to be used as a computer on their own and can be construed as a form of the coprocessor. For example, the 7909 data channel on an IBM 7090 or IBM 7094.
Hello, I am Sean Cordova from BSCS III B, and I will report for now is the ported I/O. Port mapped I/O or PMIO, memory mapped I/O or MMIO, and port mapped I/O PMIO are two complementary methods of performing input and output, or what we call I/O, between the central processing unit, or what we call CPU, and peripheral devices in a computer. An alternative approach is using dedicated I/O processors, commonly known as channels on mainframe computers, which execute their own instructions. Memory mapped I/O use the same address space to address both memory and I/O devices. The memories and registers of the I/O devices are mapped to associate with address values. So a memory address may refer to either a portion of physical RAM or instead to a memory and register of the I/O device. Port mapped I/O often use a special class of CPU instruction designed specifically for performing I/O, such as the in and out instruction found on the microprocessors based on the 86 times and 86 times 64 architectures. Different forms of these two instructions can copy 1, 2, or 4 bytes, out B, out W, and out L respectively, between the EAX register or one of the register subdivision on the CPU and a specified I/O port which is assigned to an I/O device. I/O devices have a separate address space from general memory, either accomplished by an extra I/O pin on the CPU physical interface or entire bus dedicated to I/O, because the address space for I/O is isolated from the for main memory. This is sometimes referred to as isolated I/O.
Hi guys, I'm John Rodney Ompoy. I will be reporting for DMA or Direct Memory Access.
Direct Memory Access. Direct Memory Access (DMA) is a feature of computer systems that allows certain hardware subsystems to access main system's memory, random access memory, independently of the central processing unit (CPU). Without DMA, when the CPU is using program input-output, it is typically fully occupied for the entire duration of the read or write operation. It is thus unavailable to perform other work. With DMA, the CPU first initiates the transfer, then it does other operations while the transfer is in progress, and it is finally receives an interrupt from the DMA controller, DMAC, when the operation is done. This feature is used at any time that CPU cannot keep up with the rate of data transfer or when the CPU needs to perform work while waiting for a relatively slow input-output data transfer. Many hardware systems use DMA, including disk drive, controllers, graphics cards, network cards, and sound cards. DMA is also used for the interrupt chip data transfer in multi-core processors. Computers that have DMA channels can transfer data to an unformed device with much less CPU overhead than computers without DMA channels. Similarly, a processing element inside a multi-core processor can transfer data to unform its local memory without occupying its processor time, allowing computation and data transfer to proceed in parallel.
This is Rodelio C. Martinez. Conclusion: an input-output interface is required whenever the input-output device is driven by a processor. Typically, a CPU communicates with the device via a bus. The interface must have the necessary logic to interpret the device address generated by the processor. Handshaking should be implemented by the enterprise using appropriate commands like BC, ready, and wait. The processor can communicate with an input-output device to the enterprise. If different data formats are being exchanged, the interface must be able to convert serial data to parallel form and vice versa. Because it would be a waste for a processor to be able while it waits for the data from an input device, there must be a provision for generating interrupts.